Concept 3, solving systems of equations by solving for a variable first. Alright, so far we have been given equations where at least one of them had a variable already isolated. Now we're looking at equations where we don't have one isolated. Okay? And we've got to take that step first. Okay? We've got to first choose a variable to isolate, because I can either isolate x or y, and then change my equation so that it is isolated. Alright? So what I do when I am starting one of these problems is I look for either a variable that's already isolated, okay, so it's already alone on one side of the equation, or a variable that's already just one, right? So here I recognize that I've just got one x, okay, my x is by itself. Alright, so that's going to be the easiest one to isolate and get alone so I can find out what x is equal to. Okay, so that's what I'm going to do down here. And it's pretty straightforward. Alright, same thing we've been doing. We want to get x alone, so we're going to move positive 2y by subtracting 2y from both sides. Okay, that'll cancel, and we're left with x is equal to 5 minus 2y. Okay, now that I've gotten my first equation isolated with x by itself, now I can start with the rest of my process. I can start substitution. Okay, so I'm going to substitute for x, and for x I'm going to substitute 5 minus 2y. So this right here, this 3x, is going to become 3 times 5 minus 2y minus 4y equals 5. 3 times 5 is 15. 3 times negative 2 is negative 6y minus 4y equals 5. I'm going to move my non-variables, my constants, to the other side. So put all my like terms together. So I'm going to subtract 15. Subtract 15. And be careful with this, because this is something I saw a number of people make a mistake on. When I bring this down and I rewrite this, make sure you include that negative sign. Okay? Remember, the sign to the left travels with the term. So I have a negative 6y minus 4y is equal to 5 minus 15. Okay? I have a negative, and I'm subtracting something from it, which means it's going to become a larger negative. Okay? So negative 6 minus 4 becomes a negative 10y. 5 minus 15 is going to be negative 10. And then I'm going to divide by negative 10, divide by negative 10, and we find that y is equal to 1. Okay? And yep, we still have to come back up to one of our original equations. Almost always we're going to use this one that has already got x isolated. I'm going to plug in 1 for y. I'm going to have x is equal to 5 minus 2 times 1. That's going to be negative 2. So 5 minus 2 is going to be x is equal to 3. Okay. Alright, let's do another one real quick. Okay, so this one's going to be a little bit more complicated, because not only do I have no variables isolated, so alone on one side of the equation, I also don't have any variables that are that don't have anything that they're multiplying or divided by. Okay, all of them have what's called coefficients. They have that number next to them. Okay, so what I'm going to have to do is figure out which one's going to be easiest to simplify. Okay, because I got to get it down to that 1x. Okay, So what I'm going to do is I'm going to look at this and I'm going to say, okay, x looks like it's going to be my easiest one, right? I've got 2x, it's smaller numbers. Generally, that means it's going to be easier than y, which has a larger number, and in this case an odd, which sometimes makes things more difficult. So I'm gonna be doing x. What's going to happen with this equation if I divide everything by 2, so I get this x by itself? Well, this is going to be 3, right? 6 divided by 2, but this is going to be a fraction. And I don't really want to mess with fractions unless I have to. So let's look at this one. If I divide this by 2, that goes away. I get x by itself. Negative 12 becomes negative 6. That's fine. 8 becomes 4. That's fine. 4y becomes 2y. That's fine. So I can do this one without having to mess with any fractions. All right. So that's what I'm going to do. I'm going to go ahead and divide every term by 2. 2. Okay, and then I have my 2y plus 4 equals x minus 6. All right, so now I've got it. So there's no coefficient. It's by itself. It doesn't have anything being multiplied by it. So now I've got to get it by itself, get it isolated. So I got to move this negative 6. So I'm going to add 6 to both sides. Add 6 to both sides. And I have 2y plus 10 is equal to x. And there I go. I've got it ready to substitute. Okay. Go ahead and I'm going to box that so I can tell that's what I'm substituting. And then I'm going to bring it down. This is my other equation. This 2x plus 3y equals 6. So I'm going to substitute this in for x. It's got 2 times 2y plus 10 plus 3y is equal to 6. All right, distribute. 2 times 2y is 4y. 2 times 10 is 20. Okay, then I've got my plus 3y is equal to 6. I'm going to get all my variables on this side and move my constants away. So I'm going to subtract 20, subtract 20. Those will cancel. And I've got 4y plus 3y. I'm going to speed things up and just combine those now instead of rewriting them. So I've got 7y is equal to 6 minus 20, or a negative 14. Divide by 7, divide by 7, and I have that y is equal to negative 2. Okay. Now I bring that back up to my equation that I was substituting and plug negative 2 in. A bit more obvious too, it looks like a z. There you go. Negative 2 in to this equation. So I have 2 times negative 2 plus 10 is equal to x. 2 times negative 2 is negative 4 plus 10 equals x. Negative 4 plus 10, or 10 minus 4, is 6, is equal to x. Okay, and there I'd have my coordinates, my ordered pair. 6, negative 2 would be my solution. And remember, once again, your systems of equations, when you graph them, those are those two lines, and wherever they intersect is going to be the solution.